So another thing you get with green homes, when you invest in a green home, is efficient water heating. This is a low-tech way. The cost of candles is pretty low, but no, you don't really want to do that. So water heating, the standard technology is the tanks that are heated directly by electricity, just running it through like the toaster and heating the water. Those are nearly 100% efficient, but that doesn't mean they're as efficient as these two. And the other type is the gas water heater, where you got the flame at the bottom and you're putting it in the tank. The standard electric and gas water heaters in the tanks are nowhere near as efficient as these. So this is gas. This is tankless gas. One of the big losses that you have in tank water heaters is standby losses from the heat leaking out of the tank. In a tankless water heater, you don't have that standby loss because you don't have a tank. So you eliminate the standby losses. The other loss is the firing loss, and the plastic pipe there tells me that this is a sealed combustion unit, which is high efficiency. The standard gas combustion efficiency is about 80%. When you go to the high efficiency sealed combustion gas unit, it's about 90-something percent, 94, 95% efficient. So you get a big bump in efficiency when you go to sealed combustion like that. So it's not using the room air, which is a good thing. It's also, if you look at a standard gas water heater, those things can be very dangerous if they're in your living space. Because if you have one of these in your house, go look at it. If it's a gas water heater, if you can see the pilot down below, and if you've got this metal flue on top with a bell shape on top of it and then a gap where you can stick your fingers into the flue, don't do that. It's going to be hot if the water heater's on. But that can be a very dangerous device to have in your house, because if it's backdrafting, you could be getting carbon monoxide in your air. Now, heat pump water heaters, so if you want a high efficiency electric water heater, heat pump water heaters would be the way to go. These things are like an air conditioner or heat pump or refrigerator. They take heat from one place and put it in another place. In your refrigerator, they're taking heat from inside the box and putting it into your kitchen. The air conditioner is taking heat from inside the house and putting it outside the house. A heat pump water heater is taking heat from around the unit and putting it into the water in the tank. So it's a tank unit, but it's taking heat from the surrounding space and putting it into the water. Remember I said a regular electric water heater is about 100% efficient, a little bit less than 100% efficient. On the same measure, this would be like 300% efficient. So for a regular electric water heater, for every 1 kilowatt hour of electricity that goes in, you're going to get 1 kilowatt hour of heat into the water, a little bit less. For every 1 kilowatt hour of electricity that goes in, you're going to move about 3 kilowatt hours of electricity into the water. So I mentioned this a while ago, third-party verified. This is another big benefit that you get when you invest in a green home. For most times, you're going to get somebody coming in who is measuring the air tightness. They're doing this thing that's called a blower door test. They seal up the house, they put a big fan in it, they depressurize the house, see how much air leaks out. And you can do the same kind of thing with ducts to see how much duct leakage they have. They measure airflow to make sure that you get the proper airflow in the different rooms. They do the energy modeling with the home energy rating to make sure that everything is going to be as efficient as it's supposed to be. So that's another great benefit you get. And let's get to these non-monetary benefits now, because investing in a green home is, we've spent most of the day talking about the monetary side of this, but the non-monetary benefits I think are even more important. Number one is comfort. Green homes are a lot more comfortable. Those of you who were here a couple weeks ago know what I said about that. with a really good building enclosure, good insulation, good air sealing, you're not going to have the drafts in the house. You're going to have good uniform temperatures in the house, and you'll have a heating and cooling system designed to be on more. In the cold weather, the system is sized properly so it's going to run almost continuously and provide a nice uniform heat rather than just the blasts of really hot air that you get in an inefficient house, and then it goes off and you start getting cold almost immediately. So comfort is a huge one. And indoor air quality is another one. In a non-green home, they don't pay attention to all the energy efficiency stuff. And the energy efficiency stuff is part of building science, which looks at all kinds of things. It looks at the control of heat, it looks at the control of air flows, and the control of moisture flows. And most indoor air quality problems in homes, not all, but a lot of them are related to moisture problems. Like this is a very moldy joist in a crawl space. That will get into the air in the house. This was a house some friends of mine owned. I encapsulated the crawl space, and the woman who lived there told me that she really wanted to do something about it because before they moved into that house, she didn't have a cough. She moved into that house and she had this kind of persistent cough all the time. And when I looked down in the crawl space, and the crawl space was connected to the basement, it was wide open to the basement, and they had a finished room in the basement just off from that crawl space. And there were all kinds of air leaks into the house, so this stuff does get into your house, even if it's in a crawl space. I showed this on this slide because this is a condensing furnace, and this helps with indoor air quality as well. If you have the standard gas furnace, it is pulling room air in, and so that's going to create pressure imbalances in the house, so it's going to cause air leakage, and it can also backdraft a natural draft water heater, which can put carbon monoxide in your house. So there's indoor air quality ramifications of going with higher efficiency equipment as well. And then durability. When you get a green home, it's going to be more durable. This is a house in Kentucky, and the builder built the house with no house wrap on it or anything to control the water that got behind the cladding. Not a good idea, as they discovered. They had to pull all the siding off of the house and replace all of that OSB, the oriented strand board. It's a flaky plywood. And that's an enormous expense that they shouldn't have had to incur if it had been done right. And quiet. Green homes are quieter because air travels through sound, right? I'm talking to you, my voice is traveling through the air. Sound goes through air leaks in houses. Yeah. I lived in an old house right next to railroad tracks a few years ago, and boy, the sound of the train came right through. This was the house that I built and lived in for 3 years, and we had a gravel driveway out front. If we had the house closed up, we couldn't tell that somebody came to the house until they knocked on the door. It was that quiet. So that's another great benefit. And finally, just having a really good house where people can be healthy and be happy, and where we can raise our children and have good times and bad times, but the bad times aren't because of the house. So that's a very big non-monetary benefit. And planning is very important, as Yogi Berra said. If you don't know where you're going, you might not get there. So if you're planning on building a green home, then do your homework. Make sure you know what's going on. So, and you are doing your homework by being here today. Another way you can do your homework is by visiting the Energy Vanguard blog. This is the blog I write. I write 2 or 3 articles a week. Lots of good stuff in there, and you can go there, you can subscribe to it. There's a place on the side where you can enter your email address. You'll get an email notice every time I write an article. We write about all kinds of things, power-ratic ventilators and furnaces and insulation and indoor air quality, all kinds of stuff. And my contact info, I didn't know nearly enough about HVAC, heating and air conditioning at the time. And so I hired an air conditioning contractor who had good references, and he did an okay job. I knew about the load calculation to size it properly, so I required him to do a load calculation. And he did it, and he told me that we needed a 3-ton system in this house, which turned out, when I did the load calculation later, to be about twice as big as it should have been, even in this really efficient home. And for that house, that was, remember I told you the rules of thumb that HVAC contractors use are often 500, 600 square feet per ton. His came in at about 1,000 square feet per ton. So that was still better than the typical house, but still oversized because this was a really efficient house. And he, a lot of them just don't know how to do that. So I would do a much better job with the HVAC design. Some of the moisture management details I would have done differently, used some different products and done some things a little bit differently. And the big thing, the number one item that I mentioned in that article that I would do differently is I would have spent a lot more time planning. We kind of got rushed into it because we found this land and had just a few months. We were going to close on the land and we were going to buy the land with a construction loan and start building as soon as we could. So we just got rushed into it and started building and planning and spent not nearly enough time on the planning. So, like Yogi Berra said, yeah, do your planning. That's the number one thing. Try to do as much planning as you can. And also, even with the perfect plan, you are going to have to adapt during the process. There will be things that come up during the construction process that you'll need to look at and say, oh, this is a little different than I thought. We might need to pivot a different direction or something. Well, this was counting the basement, which was unfinished. We had about 3,000 square feet. The basement was inside the conditioned space. We had about 3,000 square feet. Our average energy bills in the first year in the house were $78 a month. So a typical house that size would have been $200-300 a month, probably. So we cut the bills to about a third, maybe, of what they would have been. So, and since we cut the bills, let's say by a third, we reduced the amount of carbon from the power plant by about a factor of 9 or 10, because you have this multiplier effect. With electricity, and this was an all-electric home, with electricity, the electricity that gets delivered to your house is only about a third of the energy that went into the power plant. When they burn coal, if you put 100 units of coal energy into the plant, you're going to get about 30 units of energy at your house, delivered to your house. So you've lost about 2/3 of the energy already. So heat engines are just not very efficient. So yeah, you lose about 2/3 of the energy in generating electricity from burning coal or gas. And so for every kilowatt hour that you save in a house, you're saving 3 or 4 total kilowatt hours or energy content from the plant. And so that's a lot of carbon. That's significant. Questions?
Thank you.
Thank you. Thank you.